Okay, a light is being raised up a pole. So here's the pole right here. And we're raising the light up it. The light shines on an object Q. Maybe it's this guy over here, like a bush or something like that. Who knows? Okay. And it casts some shadow, this length right here. Okay, so the length of the shadow, this is the shadow right here. Okay. At a certain moment, the light is 40 meters off the ground. So let's go ahead and give it. So it's 40 meters high. And it's rising at 5 meters per minute. So let's call this some variable. Okay, we'll call it height. So the rate of change of height with respect to time is equal to 5 meters per 1 minute. So that's some information that's given to us in the problem. Okay, we also know that the height value, we don't know what time this occurs at, but the height that we're specifically looking for is 40, the object, the light, is 40 meters high. Okay, now what we're asked to find how fast is the shadow changing, or is it shrinking? So let's just call this shadow S. So what we want, I'm using different variables in the book because I want you to get used to using stuff other than Y's and X's. So this right here, S is also a function of time. Okay, we don't know exactly what it is, but we're going to be able to figure this out. Okay, I'm going to get a value here. What we're looking for, what we want to know, is how is S, the shadow length, changing with respect to time. So this is what we want. Now what we need to do is we need to set up an equation that relates to all this stuff. Okay, so let's see if we can't figure a couple things out. Well, at 40 meters high, we've got two triangles. We get this bigger outside one and this smaller inside one. And so these triangles, both they're similar to one another. So the corresponding parts are congruent. What I mean is that I can make ratios from this guy over here. So what I'm going to do is I'm going to say, okay, well, these are both right angles. Okay. And so this smaller one right here, the equation can be given by the following. We know that, well, let's set it up like this. I guess maybe the best way to do it is H. If I use, I want to stay away from the trig functions because we haven't discussed them yet. So let's do something like this. 40, this length, over 10. This length over this length has to be equal to this full length, 20 plus the shadow, over just the shadow, like that. So we can go ahead and do some rearranging if we want to. Okay. But what we've got here is we've got our 40 over our 10 equals the 20 plus S over S, because we don't know the length of the shadow. Now, what we can do here is we could solve this guy, and we can tell the length of the shadow at a height of 40. So this should be solvable. So we've got 40S is equal to 200 plus 10S. So if we subtract S from both sides, we have 30S is equal to 200. Now this is in meters, okay? So we'll divide each side by 30, and so that'll give me 20 over 3. So at whatever time this is, I don't know exactly what time. I should say t, well, let's just call it t naught, okay? So at t naught, the length of the shadow is 20 over 3 meters, so approximately 7 meters, okay? And the height is 40. Now in general, the relationship between those, let's use a different color. In general, we've got the following. We've got h over 10 is this guy over this guy should be equal to this long guy, again, 20 plus s over just s. And so if we solve this for h, okay, we end up getting the following. Well, let me just go like this. This is going to be h times s is equal to, again, 200 plus 10s. And if we divide everything by s, assuming that s is not 0, the shadow length is not 0. If the shadow length was 0, this guy would have to be infinitely high, right? Okay, so that's not really a possibility. So we're going to say h is equal to 200 over s plus 10. So this is, we can think about this as h as a function of the shadow length, or vice versa. We could solve for s, okay, and get what h is. Okay. So what do we have? Well, I'm gonna, just so it doesn't confuse you, I'm just gonna write it like this again. Okay. Now we got this information up here, and we're gonna use that. So what I'd like to know is, what is the rate of change of s with respect to time? How does the shadow change with respect to time? So to get that, we're going to take this guy right here. So h is equal to 200 over s plus 10. Or another way to write that is h is equal to 200 s to the negative 1 plus 10. Now let's go ahead and take the rate of change of this with respect to t. So dh dt, okay, I'll write it like this so you can see the whole chain rule. So this is d dt of h is equal to d dt of 200 s to the negative 1 plus d dt of 10. Well, d dt of h, I can't do that. H is a function of t, so let's go ahead and rewrite that. So this is going to be dh dt times ddh of h. There's my chain rule. Here, again, s is a function of time, so we have to go ds dt times d ds of 200s to the negative 1 plus d dt of a constant is 0. So this gives me dh dt. Now ddh of h is 1, so I'm not going to write that there. Then this is ds dt, the rate of change of the shadow with respect to time. Now I got to multiply that by the derivative of this guy right here, which is going to be negative 200s to the negative 2, like that. So let's rewrite this. dh dt is equal to negative 200 over s squared times the rate of change of the shadow with respect to time. So the change in the height with respect to time is equal to this. Now, it's probably more logical to think about it because we're thinking about really the height's the guy that's moving, and then the shadow is impacted by it. So it's probably a little bit easier in your head to think about it like this. The rate of change of height with respect to time multiplied by s squared over negative 200, that is how the shadow changes with respect to time. Okay, so notice that dh dt is 5 meters per 1 minute. So we can go ahead and insert that in here. So 5 meters per 1 minute multiplied by the shadow length squared over negative 200. This, of course, is this guy right here. Well, I'll forget about the units. Okay, we'll just go ahead and multiply this out. And this ds dt is what we don't know. Okay, like that. So, but we do know what s is. S, at that exact moment in time, is 20 over 3. So this is going to be 20 over 3 squared over negative 200 times 5 over 1. That is how s is changing with respect to time. And so what I'm going to do is just multiply all this stuff out. So we'll do the computation here. So this is going to be 20 times 20. Okay, so 400, I'll write this like this. It's going to be 5 over 1 times 400 over 9 times 1 over negative 200. Okay, so the 400 and the 200 give me just 2. So this gives me just a 2 up top here. So I multiply across, I got 5 times 2, which is 10. And the bottom, I've got 9 times negative 1. So it's negative 10 ninths. And so just about negative 1 meters per minute. So the shadow is decreasing by approximately 1 meter per minute, or negative 10 ninths meters per minute. So it's really, what does that give me? I think it gives me a negative 1.1 repeating. Okay, so that's how we go ahead and work this guy out. The hard part is going to be setting up your equations and making sure that you take the derivative correctly as you go through and substitute in the right values.